Figuring out messy handwriting, like a note someone scribbled down really fast, feels like a purely human thing, right? Our brains just seem to get it. But what if a machine could learn to do the exact same thing? Well, today, we're going to break down exactly how an artificial brain learns to read, and we're going to start with just a single kind of sloppy number.
So take a look at this. For you and me, that is instantly a 3. No question, doesn't matter how messy it is. But a computer? It doesn't see a number at all. It just sees a grid of pixels, basically a bunch of dots. So how on earth does it get from a simple pattern of light and dark squares to the actual idea of the number 3?
Okay, so this is where the real magic and the challenge begins. The very first step in teaching a machine to see something isn't really about being smart. It's all about translation. We have to somehow convert that visual, handwritten thing into a language the machine can actually understand. And for a computer, that language is, and always will be, numbers.
And here it is, that first big translation step. The image of that 3 basically gets a grid laid on top of it, and every single tiny square in that grid is about to become a piece of data. This grid is literally how the machine starts to see the world, one little pixel at a time.
So how does the machine take its first glance? Well, it's all about turning those pixels into the very first layer of our artificial brain, what we call the input layer. Come on, let's build it out. First, we got to establish the size of our grid. For this classic example, we're working with a canvas that is 28 pixels high.
And you guessed it, 28 pixels wide. It's actually a pretty small and simple canvas, but trust me, it is more than enough for the computer to start learning.
So do the math. 28 times 28 gives us 784 total pixels. And here is the really important part. Every single one of those 784 squares becomes its own individual input. It's a single piece of data that we are about to feed into our artificial brain. Now you might be asking, what's in those inputs? Well, it's a value we call activation. And honestly, the easiest way to think about it is just brightness. Each pixel gets a number from 0 for totally black all the way up to 1 for totally white. So when you draw a number, the pixels that make up the actual line of the digit get activated. They get a high value, something close to 1. They are literally lit up for the machine to see. Okay, so the machine has its 784 inputs, each one with a brightness value. What happens next? All of that data gets fed into something called an artificial neural network. Let's crack this thing open and see how this brain actually thinks in layers. So the whole journey kicks off at the input layer, which is pretty simple. It just takes in those 784 raw pixel values. From there, the data flows to the first hidden layer. Now this layer isn't looking for a 3, no way. It's been trained to spot much simpler things, like tiny little edges or small curves. Then, the next hidden layer takes those simple patterns and learns how to combine them into more complex shapes, like say, the top loop or the bottom curve of our 3. And it's only at the very end, in the output layer, that all these different pieces finally get put together to make a guess, activating the neuron for the number it thinks it sees. But wait a second, how does the network know which little edges and curves are important? Well, it learns by tweaking 2 key tuning knobs. First, you've got weights. Weights basically decide how strong the connection is between the neurons. You can think of it like turning up the volume on the pixels that actually form the number while turning down the volume on all the background noise. Then you have bias, which is like a final little fine-tuning nudge, just to help the network's output be a little bit more accurate. So how does the network even know how to adjust those weights and biases? This is the beautiful part. It learns from its own mistakes. This is the learning in machine learning, and it's this powerful feedback loop that is constantly making the network smarter and smarter. This whole learning process is guided by something called a loss function. It's basically just a formula that spits out an error score. Every time the network makes a guess, the loss function tells it exactly how wrong it was. The entire goal of this training game is to get this score as low as you possibly can by constantly tweaking all those weights and biases we just talked about. And this chart makes it super clear. If our network sees our 3, but it guesses 8, the loss function gives it a really high error score. But when it correctly guesses 3, boom, it gets a nice low score. The network then works backwards, making these tiny little adjustments to its weights and biases just to make sure that the next time it gets an even lower score. And it does this thousands, sometimes millions of times. What's really clever about all this is that the network doesn't just learn to be right, it learns to be confident. A correct guess with high confidence, that's the jackpot. But a guess that is both confidently made
and wrong gets a massive penalty. This teaches the system to stop making strong, incorrect assumptions, which, let's be honest, is a pretty crucial part of getting smarter. So we've gone really deep into one specific process here. Now let's kind of zoom out and see where this technology, the artificial neural network, fits into the grand scheme of artificial intelligence.
I like to think of AI as a set of those Russian nesting dolls. The biggest doll on the outside is artificial intelligence. That's the huge, broad idea of just making smart machines. Open that up, and inside you've got machine learning, which is the specific idea of systems that learn from data. Go one level deeper, you find deep learning, which uses these huge, multi-layered networks. And right there at the very core, the tiny doll driving everything, are the artificial neural networks we've been talking about. So really, when you boil it all down, it's this fundamental engine, the artificial neural network, that's powering so much of our modern world. The same basic idea that learns to read a 3 is what lets your phone recognize your face or a translation app understand a sentence. It's the core building block for some of the most powerful AI we have today. So, there you have it. We've seen how from just one messy number, a machine can learn to see patterns, make connections, and actually get smarter from its own mistakes. This one simple process has totally unlocked a universe of possibilities. Which leaves us with a really fascinating question. Now that machines can read our writing, what are they going to learn to do next?